So welcome back, everyone, to yet another exciting week of programming for psychologists. Hopefully you are all raring to go once again. I chose this comic strip this week in honor of the bugs that you guys all managed to find last week. I think people experienced some unmatched left parenthesis issues last week, which is a tried and true experience in programming. So hopefully you guys will be well familiar with this bug, but every time you do it, you're slightly less likely to do it the next time. So hopefully you'll get better and better at that as time goes on. Okay, so what we're talking about today, talking about functions and sound in PsychoPy. So that's going to be pretty exciting, I think. Yay! And actually, so yeah, we're gonna make some pretty significant progress, I think, in the stuff that we're able to do today. So this will be pretty cool. You'll find the sound stuff is actually going to be pretty easy and pretty simple. The function stuff is a little more like cognitively challenging in a way, just conceptually. But after today, you'll have really most of the tools that you need. I think I might have said this before, but it's even truer today. Most of the tools you need to make some really sort of sophisticated experiments happen. So in terms of problem sets, I regret to inform you that because we had the conference this weekend, I am not still 100% done with problem set 1, and thanks. Hope that'll still be okay for the podcast. I think it will. You don't want me to, not show up, because otherwise, how will you ever get through the podcast? So I'm nearly done with problem set 1. I've looked at problem set 2. It looks like people did a pretty good job on problem set 2, but that's going to be top priority now that we're sort of back to normal with no conferences or things this week. So I promise you guys I will get your marks back to you for both problem sets this week, hopefully. I'm working on problem set 3, but I may adjust the difficulty a little bit depending on how you guys did on problem set 2. So I'm assuming you're okay if problem set 3 doesn't go up till maybe like tomorrow, but it gets a little bit easier as a result. I'm assuming you guys would probably be okay with that. So that will probably be the case. I think people did well, but I want to see exactly how well you did before I decide how hard to make problem set 3. So I'm going to work really hard on getting that caught up, but it looks like people did a good job. So I think next time maybe we can talk about some of the details. And I still have to figure out exactly how I'm going to return your marks to you. I think it's just going to have to be via email. I had some crazy idea that we have some kind of encrypted system where you could only download your own marks, but that seems really too complicated to set up for both of us right now, so I think I'll just email them back to you. Okay, any other questions or general issues or things before we get started today? Okay, so just to let you know sort of what my plan is for the problem sets and otherwise, I think people are doing well, but I've been pretty easy on you guys so far in terms of how much independent thinking I've been forcing you to do in the problem sets. So that's going to keep increasing as time goes on. So what I'm going to try to do is sort of slowly increase the amount of independent creativity it's going to need to do these problems, while at the same time having you do a little bit more handheld practice on the most recent things. So I'll keep holding your hands with things like sound and graphics and things like that. But I'm going to also try to start making you solve some programming problems that really make you think a bit. So I'll try to balance those things to make it not break your brains too much. But it looks like for the most part, no one's brain was broken too much by the last problem set. So we're going to try to keep it at a similar level where it takes you a few hours, but not like a crazy amount of time. Okay. And as always, feel free to come ask me if you get totally stuck, or ask each other, because you shouldn't be hammering away at something for 2 days, the same problem. So feel free to come for hints if you need to. Okay, so let's talk about today's topic. If you can remember all the way back before the Malaysia Psychology Conference, before all the crazy fun events of this weekend, if you can remember all the way back to last week, we talked about object-oriented programming. And we talked about, that in contrast to the idea of procedural programming, right? We said procedural programming is sort of like the functions you learned back in algebra class, or we said it was kind of like, sending something through a series of machines at a factory where you put something in to the G machine and get out a different shaped object, and then you put that into the F machine, and you get some other object out and so forth, right? So those were the good old days when we had objects and things that we were talking about. But today we're actually sort of taking a kind of a step backward in programming history and talking about functions, okay? So, obviously in real history, procedural programming and function-based programming came a lot before object-oriented programming, but we're sort of doing the inverse thing just for reasons of how easy it is to explain these things conceptually to you. So this week we're talking about programming with functions. And basically the reason I decided to do it in this order is because using objects is easy, probably easier than making your own functions. But making new types of objects is pretty complex in Python and just in general. So like you guys will never need to create a new type of object. You know what I mean? So like it is possible, of course, in Python. Like somebody had to create the class of objects that represents windows or circles that you draw on the screen or images that you draw on the screen. But you won't have to do that kind of stuff. You only have to use the predefined object types that come built into Python into PsychoPy. But, so we'll be using these pre-built types that we've already talked about, but we will find it useful for you guys to create your own functions, which is comparatively easier to do. So, making your own functions is a little bit easier than just using objects, but it's still, what did I say? Creating your own functions is a little bit harder than just using objects, but it's so much easier than creating your own types of objects, which we won't cover in this class. Okay, so that's what we're talking about today, not just using functions, which we kind of have done already, but actually defining and creating our own types of functions. Hey, you can come on in and use the computers, but we are podcasting, so just, keep it down or else you'll be on YouTube forever. You might go viral. Okay, so when we talk about functions in Python, what are we talking about? So, again, we've used these analogies before, like factory machines and things like that, but essentially, in terms of the actual Python language, what you're basically doing with a function is grouping together several Python commands together under a single name so that you can invoke them or cause them to run all at the same time, right? And there are a lot of reasons why this is useful to do and why functional or procedural programming is useful. So one just basic reason, if you didn't use functions for any other reason, is that it will save you lines of code, right? So if you have like 5 commands that you're always calling in exactly the same way right in a row, you can just collapse those into a function. You define the function once, and then every time you want to call those 5 commands, you just use a single line of code, right? So that can be really useful because it just shortens the number of lines of code required to run your program. And as such, it makes your code a lot easier to read, right? Because if you think about computer code, you could, if you really wanted to, you could take even something with like millions and millions of lines of code, like your operating system or Microsoft Word or something like that. If you really wanted to, you could put every single like command that the program runs in like straight linear order and have like one giant text file with like 200 million lines that all compiles at the end. But that gets that would get really painful and difficult to actually find anything in that file if you want to change anything, right? So it makes life a lot easier if you can kind of take chunks of things that you tend to run together and put them in their own little files, or kind of get them just right and put them aside, so that then your main program is much easier to read because you only have a few lines in it. So that's one reason we're going to be doing this, and one thing we'll be doing in just a minute here. So it makes your code shorter and more readable. It also makes it a lot easier to reuse code you've already written and saves time. So again, we're all about, programming is all about learning to be lazy in a smart way, basically. So once you figured something out once, there's no reason you need to figure it out 10 times as long as you kind of remember, what you did the last time. So this is an easy way to reuse code. You don't have to go and find it every time if you have a function defined that does exactly what you want. And basically what this does is it allows you to program with greater abstraction, right? So again, it's this whole idea of packaging things up and bundling together simple commands into commands that are more complex but more directly express what you want to do, right? So then instead of giving Python or PsychoPy 10 separate commands to draw 5 things on the screen, if you're drawing those 5 things on the screen in every trial, you might say, all right, well, I'm just going to make one function to draw those 5 things on the screen, and then each time through my trial, I'm just going to call that once, right? So, it makes it easier to get close to your mental ideal of display this slide at the trial without having to think about the details more than once, right? So the whole idea is, whatever nitpicky little details you want to think about, you want to come as close as possible to the case where you only think about them once, figure it all out, get it perfect, and then you just call some single simple command from that point forward. And this is just terminology to note. You also might hear these referred to as subroutines, procedures, or like we heard last week, if it's part of an object, they might be called methods, okay? So I will usually call them functions, but if you see subroutines or procedures, they're basically the same thing. Some programming languages draw a distinction between these words, but we won't really. But methods is what we usually call them when they're part of an object, and just functions otherwise. Okay, so one other analogy I wanted to make about this. So this whole idea of abstraction, one way you can think about this is if we continue the metaphor that functions are like these factory machines, right? You can think of it as like, a factory machine is itself, if you've got this machine back here, so you've got this machine here, the G machine, that turns spheres into cubes, right? So if you had an actual factory machine that did this, of course that factory machine would be built out of parts, right? You might have some screws, and you've got some, pieces of aluminum, and you've got some, masher things to like turn the sphere into a cube or whatever, right? You have all these individual simple mechanical pieces, right? But every time you want to use the G machine to turn a sphere into a cube, you don't want to have to think about every single screw that was used to build that machine, right? You just want to think about the machine as a complete thing. So that's kind of the idea with functions, right? It's like every time you want to toast bread, you don't like get a bunch of screws together and a bunch of wires and make a toaster from scratch, right? You have this pre-built toaster, and you can just use the toaster every single time. And that's what we're trying to do with functions, is essentially build toasters so that you don't have to, assemble every single gear and screw and spring and lever every single time. Okay. So, again, continuing this factory machine analogy a little bit further, one thing a function can also do, besides just lump commands together, is transform or map inputs into outputs, right? So it can take in inputs, it can spit out outputs. Now, unlike the factory machine, you don't have to have inputs and outputs in a Python function. You could have both inputs and outputs. You could have, just inputs but no outputs. So you take in a sphere and spit out nothing. You could have only outputs, so you're creating, cubes out of nothing seemingly. Or you could have neither, right? You could have a machine that just does several things but produces no actual input or output. So the factory machine analogy kind of breaks down a little bit here. So you've already seen a lot of examples of these. So like these draw and flip functions, I know I haven't fully explained flip, but you've seen draw happen, right? So draw and flip don't take any inputs or produce any outputs, right? No, they do something. They, like the draw function, draws the object onto the screen, or it draws it onto the sort of screen, the invisible screen that then gets flipped to be actually shown on your physical screen. But it doesn't actually take any information in or spit any information out, right? It just does some task. So these don't take either input or produce output. You can have something that takes in input and produces output. And you guys have used, for example, random.randint to generate a random integer, right? So random.randint, you have to tell it what range you want the random integer in, right? So that's the input. And as output, it gives you a random number. So it has both input and output. An example of a function with only output that you've used is random.random, that just gives you a single random decimal number, right? So that one, you don't have to tell it anything in specific. It just knows that what it does is give you a random number, but it does produce output, right? So without any specific information being given to it, it gives you an output. And something that takes only input, for example, might be the print statement, right? Because you tell it what to print and it does it, but it doesn't give any information back to you, right? I mean, it puts something on the screen, but it doesn't return any information in the Python language back to the command that called it. Okay? Does that kind of make sense to people? Everyone see kind of how you can have input or output or both or neither? Hopefully you do, because we'll be doing this in just a second. Okay, So just a little bit more on what inputs and outputs are, and then we're going to talk about how you make a function. And this will all make a little bit more sense when we actually do it, I think. So just some more terminology. When we talk about the inputs to a function, so like what you put into it to make it do its thing, other words for these are arguments and parameters. Okay, so you might hear them called this in other contexts. So if I call something an argument, I don't know exactly the history of why we call it an argument. But when you think about when you have an argument with someone, you're sending information back and forth with them, sometimes at a very loud volume, right? But you are sending information back and forth when you argue. So you can think about that as a way of remembering what an argument is in programming. It's just information that you send into the function. And parameters is just another term for inputs. Outputs, you might also see them called return values, and you'll see why, but basically it's a value that is returned to whatever script called the function. Or sometimes you see them called output parameters, but we'll just usually say inputs and outputs. And a few other notes about them. So you can give a function any number of inputs. I mean, it has to know what to do with those inputs, but there's no limit on how many inputs a function can ask for. And it can also have multiple outputs, but talking about that is going to be a little bit tricky until next week. Okay, so for right now, let's just assume or focus on functions that only spit out a single output and not worry about how you might return multiple pieces of information. Okay, so that's again just stuff for your reference, but it'll make some practical sense pretty soon here. Okay, now in terms of how you actually make a function. Functions are awesome. They're going to make your life much easier once you figure them out. So we use the awesomest keyword in Python, which is called def. And we know that anything cool, you can use the word def to describe it, like Def Leppard, Def Comedy Jam, or Most Def. So if something is def, it has to be pretty amazing, right? So we're going to use it actually stands for define, right? So you can define your own function. But functions are pretty great, so that's a good way to remember the def keyword. And that's what we're going to use to create functions. So what we're going to do first here is actually take our previous demo that we worked on and just kind of simplify it a bit by making a function to collapse some of the frequently used lines of code into a single function. Okay, so this is a principle I think it's worth noting that you do in real programming sometimes, which is when something starts getting kind of complex, you sometimes want to take a break, stop adding features to it, and simplify, right? So because all of my examples come from Apple, of course. A good example is, usually when you have a new version of an OS, this is from the 5th version of the Mac OS, Leopard, you add all these new features and you brag about them and you say, look at all these cool things we added. But if anybody can remember back to, I think it was about 2008 or 9, when Snow Leopard 10.6 was released, they bragged about adding 0 new features in Snow Leopard. Because what they decided to do with that release of the operating system was say, all right, we've got this really nice operating system as it is, but the code's kind of complex. We've got all the support for old devices that no longer exist. So we're going to focus on this release and just kind of trimming the fat, making things run faster, making everything run better, taking out bugs, and not add any new features this time around, right? And that can be a really useful thing to do sometimes because it makes it much easier to then continue developing your code if you kind of stop and condense and simplify every once in a while. So that's what we're going to do actually right now in a very small way, not nearly as much as they do when they revise a whole operating system. So we're going to do that with our old demo code from last time. So go ahead and, ladies and gentlemen, start your PsychoPy engines. So we should be at, let's see, did we stop at number guess 4? I think that was the last version. So I'm going to just save this as number guess 5. Okay, so we've got this function. We've got about 44 lines of code here, right? Everybody got this loaded up. I'll give you just a minute. This is the version. I'll run it again from last time if you forgot it. Should still work in theory. That guesses numbers, guesses them randomly, and it puts up however many smiley faces. So it puts up 78 smiley faces, 87 smiley faces in random locations. So we're going to keep the same exact version of the number guessing game but we're going to see if we can reduce some code here. So if you look through here, if you remember when we first wrote this code, we did some copying and pasting, right? So we kind of reused some of the code several times here. Anybody see some cases where we did that, where we have code that kind of appears in basically the same form more than once? I will give you a hint. There's an example on the screen right now. So where do we see two chunks of very similar code here? What line numbers? Okay, I think I heard what? Starting at 11 and starting at 16? Yeah. So this is a good example, right? So every time when we first wrote this, every time we wanted to write some text on the screen, we use these same 4 lines of code where we make a text stem with the right text in it. We draw it to what we call the buffer, which is sort of the invisible screen that we get our stimuli ready on before we flip it with the next line and show it on the actual physical screen. And then we use this wait keys event to wait for a key press before we go on, right? So we do that again here in lines 16 to 19. We kind of do a similar thing here, but that gets a little trickier because we're doing something slightly different. And then we do it again right here at the end, right? So we use these same 4 lines of code 3 times in this function, which is not the worst thing in the world, right? It's still only 44 lines of code total to do this whole thing. But again, you can imagine if this was a 500-line function or a 2,000-line function, the more lines you could reduce, the better it is for being able to find bugs and do things like that, right? And again, there's just no reason for things to be redundant. If you're doing, these same 4 things over and over again, you may as well condense them down and make just one thing out of them, right? Okay, so what we're going to do is we're going to try to define a function that takes basically these 4 lines of code and condenses them into one. And one kind of slightly annoying thing about Python is the function definition has to come before you actually use it. So right now, I'm going to put it up at the top of the file, and then we're going to talk about some ways to make life a little bit easier than that. So right now, I'm just going to put it right after the import statements at the top of the file. So I'm going to use def to define a new function. And so what I'm really doing down here, right, is displaying some text. So I'm going to call this new function, let's call it display my text. My function names are not super original, but that's okay. And if you guys remember, or if you can even look down here, you can see that what we've been doing when we call functions, right, is we have to pass in some information, like what window to put it in, what the text is going to be. Now we're going to actually make our own function that requires certain information. So let's think about what information we're going to need. Well, we're going to need to be given a window. So let's say there's a window that we're going to need. So what you do is you put in parentheses, and you're going to basically, these are going to be our inputs or our parameters, and we get to name them whatever we want. So these are really just variables, but they're variables that don't take on a value until someone calls this function. You know what I mean? So in other words, we're giving names to the things that someone needs to tell our function. Okay, so one thing we're going to definitely need is a window. We're going to need a string of text to display, right? Because that's what we're doing, is displaying text on screen. So we need to know what the string is. And we might also give people a few options like what font to use. So, because that's something that we have to do. I'm going to point to the screen, and that's not going to help anyone. We have to give the font, right? So we may also want to take in information about what font we need. Okay. And let's see, what else might we need? We might need to know, oh yeah, what height the text is. So let's call one height. Let's see. Oh, and the last one we used, if you remember, is what we called wrap width. So we'll do that too. You can call it whatever you want. I'll do wrap underscore width to distinguish it a little bit from what PsychoPy calls it. You just have to remember exactly what you call it. Okay, so those are really the 5 bits of, 5 bits of information we're going to need to put text on screen. And then what we're basically going to do is take these. So if you ever, you know what you need here? You need a colon, just like you do with a while statement or an if or anything like that. So a colon here, and then you'll get an indent. And this is just like an if statement or a while loop or a for loop or anything where it ends with a colon, it indents, and then everything that's indented becomes part of this function. And then what we're going to want this function to do basically is these four things that we're doing down here, right? So we're going to copy this code. We can paste it up here. We'll have to add in tabs to make these part of the function, or 4 spaces if you prefer. The tab should be expressed as 4 spaces. And now we might have to change some names because we changed some names of things, right? So, so my text is okay. So we're naming a variable called my text, and that's going to be psychopy.visual.textstem. Here, we changed the Windows name to just window. So let's just edit this to be window. And then when we create a text stem, we still give it the text, but actually, we're not giving it specific text anymore, right? Because this is a general function for doing this. And again, I'll explain this once we've written it so you can kind of see what we're doing here. So the text is now going to be, the text in the text stem object is going to be whatever string people give to this function. So we'll say text equals string. This is going to look a little confusing here because font will equal font. Because basically, the text stem is expecting an input named font, and our variable is also named font, so we just say font equals font. Let's say for the moment that all the text we ever write is going to be bold, because I think that tends to look better. So let's just say bold is true. Height is going to be, again, whatever someone gave us for the height. So that's fine. Oops. And the wrap width, we just changed the name a little bit to wrap_width. So that's that. And then we've got mytext.draw. We changed the name of the window to window, so we'll change that here. And then we've got a psychopy.event.wakekeys. All right, so these we don't really have to change much. So basically what we've done here is we've defined a function that's meant to display some text, draw it on the screen, flip the screen over, and wait for a key press. And then control will return to whatever point in the code called this function. And what you have to tell this in order to make that happen is you have to give it a window, a string, name of a font, the height of the font, and the width of the text so that it will wrap around if it gets to the end of that line. Okay? So now what we have to do is we have to actually use this function because this code right here only defines it. This just says, now there's a function called displayMyText that you can use to display text. To actually use it, what we can do is we can go down here, we can just delete these lines of code, and actually most of this line of code. But what we want to do is instead of these 4 lines of code, we want to just call displayMyText. Now what displayMyText is expecting is a window. So we've got one here that we called myWindow, right? So we're going to give it myWindow. The next thing displayMyText expects is a string. So we'll give it this string here with the quotes, right? The next thing it expects is a font. And that's actually what we had before. So we already have font equals curly or new. That's okay. The next thing it's expecting is a height and then a wrap width. So we can take out the bold part because we didn't make that part of our function. But we do need a height, and we changed the name of the wrap width a little bit. So we want to make that wrap_width. All right, now there's a lot I'm not explaining in this one little bit, but I want us to first just try this and get it working. And then we're going to explain some details of what we're actually doing here. So I know it's a little confusing. All right. Oh, shoot, I just saved over the old one. No, I didn't. It kills me how this doesn't update up the top here. It's always getting me. All right, so let's see if this just works. Now, what should happen here is we should get the exact same function as before, but now using our own function instead of those 4 lines of code. All right, looks like it worked, right? Nothing crashed. All right, let's try and run that again. So when it says I want you to think of a number between 0 and 100, it shows the same thing it did before, so that's fine. Okay, so that works, which is good. But of course, that's not too useful yet, because all we did was take like 4 lines of code and replace it with like 6 lines of code. So far that's not making life any easier. But you'll see now what will make life easier is we can also replace this code down here and do kind of the same thing, right? Where we say, all right, now we're going to replace this visual.txt and everything once again with display my text. And again, I'll explain some finer points here about some things I'm doing as we go. So again, we're going to give it my window. Now we're going to give it a different string. Give it the same font. Take out the bold part because we decided we're going to print all our text in bold. Height is 36. Wrap underscore width is what we called it in our function. Place that all. See if that works. Okay, so that still does the same thing, which is good. So we haven't broken anything yet. And again, we can actually go down here once more and replace this line of code, or these lines of code, with our new function. So again, we can just go take out a bunch of this stuff and call, what do we call it? Display my text. We give it my window. We say the string is I knew it. I am also pressing key to exit. Give it the font. Take out the bold part because we decided we're just going to make them all bold. Height is fine. Wrap width, we changed the name to wrap underscore width. Save that. Run it. No. Yes. Okay. So all that works exactly like before. Now, it's not an amazing savings of lines of code, but we've cut our 44 lines of code down to 40 that do exactly the same thing, right? And it's a bit simpler to read because every time we had those 4 lines of code, now we just have this one line that does this display my text thing, right? Now, I pulled a lot of tricks here that I didn't tell you guys about right away because I just wanted you to see it work. So now we're going to go and break down a little bit more what we just did here. So again, what we did up here when we defined this function is we defined some parameters, right? And I decided that they should be called window, string, font, height, and wrap width, right? And then now you're making certain assumptions about these, right? So when you call them this, these are just names, but what you're assuming is that the person using this function is going to know what all these things are. So in order for this code to work, the window has to be an actual PsychoPy window object, or else things are going to go wrong because you're giving it to this text stem creator. You know, you're passing the same window on to that. And if that's not a real window, you know, if you give it a number or something instead of a window, it's going to freak out. It's going to crash the program, right? And similarly, you call it string here, but there's nothing forcing it to be a string that someone passes in. So you would better hope that somebody actually gives you a string here or your code's going to crash, okay? So one thing to note is that Python, there's no way that you, there's no way in the code that you tell Python what type of object you're expecting to get in here, or at least there's no way that we're going to do that. So for the moment, it's just going to be upon you to tell yourself what sorts of objects you're expecting these things to be and to use them appropriately, okay? And if you're writing, if you're writing documentation for your code, you would probably want to put some documentation that says something like, window argument should be a PsychoPy window object. String argument should be a Python string. Now we're adding lines of code, but this is more documentation, so it's okay. Font argument should be a Python string with the name of a valid font on the system, or something like that, right? Now this is one thing we haven't really talked about, is documenting your code and being a good programmer in that regard, but this is something that's often good to do, right? Is if you have all these arguments and it's not totally clear what each one is, it's good to sort of document what they should be. Height argument should be an integer in, I think it's in pixels. Let's say it's in pixels. I think that's what it is. And wrap with argument should be an integer in pixels. I think that's pixels also. Okay, so, I mean, and again, you don't have to write exactly what I wrote, but the point is, it's up to you to sort of decide what your parameters are and decide how you use them inside the body of the function, right? So this is something that's good to do, is to define what your parameters actually are, so that someone looking at your function, or you know, in 2 weeks when you come back to this and you look at your code again and you're like, what are these things? So that you can figure out what these things should actually be. Now, again, there are a lot of fine points here that I didn't explain the first time. So one of these is, we've given these things the name window, string, font, height, and wrap width, right? If you're just commenting, you can stop typing for a second and pay attention, because you know, the comments are really just there for illustration. They don't affect the code. So another thing worth noting is down here, you might notice some inconsistency in the way that we've called functions before, right? So here, like in display my text, we have my window, we give it my window, we give it a string, which is this string. But then sometimes, and I did this sort of inconsistently on purpose, sometimes I do this thing where I say like font equals or height equals or wrap width equals, right? And sometimes sometimes I have this weird sort of equals syntax. And sometimes I just give it a thing, right? Either the name of a variable or an actual thing like a string, right? Now, if this is confusing to you, it's reasonable that this would be confusing to you, because this is sort of a confusing thing about Python, is that it lets you do things a lot of different ways. So basically, when you specify your own function definition in Python, you have you specify in the define line or the def line that you're expecting a certain number of arguments, and that they're going to have certain names, and of course they're listed in a certain order, right? Now, if you're calling this function, you can specify what the inputs are to this function in one of two ways. You can either just send in 5 things without naming what they are. So you can just send in 5 things, and the function will automatically assume that the first thing you send in will be a window, the second thing will be the string, the third thing will be the font, the fourth thing will be the height, and the fifth thing will be the wrap width. However, Python also lets you do this kind of funky thing where you don't worry about what order the things come in. You can specify what the names are. So for example, you can say, let's replace this one. Let's replace this one so that we say, all right, the first thing I'm going to put in is going to be the string. Now this would not work unless I say string equals this, right? So what I've done is I've gone up to where the function's defined and I said, okay, it's expecting something to be passed in, an argument that it's going to call string. So down here, I'm going to tell it that the string argument is going to be this string, so string equals that. So in other words, this name string inside these parentheses where we're calling this function, this name string refers to what it's going to get called in the function definition. It doesn't refer to anything that's named string in this line of code, right? Because around here we haven't defined anything called string. We're saying I want this literal string, in quotation marks, to be given to the parameter string. I know this is confusing, up in the function definition up here. Does that kind of make sense to people? Everyone get that? So if we wanted to change the order we pass these things in, we could say, all right, string equals that, and then we could say font is courier new, but we could also say font is courier new. We could cut that and put it at the end. You know, we could say, and then we'd have to put in window again, right? Because it's still expecting a window. So we'd say maybe window equals my window. My window here. Font equals courier new. So you can move the order of the parameters all around versus the way they're defined, as long as you name all of the parameters so it knows which ones to put where, right? So if we run this, in theory, it should still work. Okay, so that still works okay. And to do it the exact opposite way, we could also put in all the parameters in exactly the right order and not name any of them, right? So we've got my window, we've got the string. We don't have to name the font as long as it comes in the right position to be the font. We don't have to put in the name height as long as it comes in the right position to be the height. And we don't have to put in the word wrap width as long as it's in the 5th position. And let's see if that still runs. Okay, it does, right? So that all still is treated okay. So this is a thing that's a little bit confusing about Python. So I'll just tell you, like in most programming languages, this is not the way it works. In most programming languages, you're expected to specify the parameters in the same order every time. So Python's a bit funky in that it lets you bend that restriction as long as you name the parameters something that makes it clear which is which. And it's a bit weird also because you can also mix and match between those systems, right? So it gets really complicated if you start mixing and matching. What I suggest that you guys do to be on the safe side is that you both put them in the order specified and you also name them just to make things totally clear. So my suggestion for you would be, if these are called window, string, font, height, and wrap width, that you actually say window equals my window, string equals that, font equals courier new, height equals 36, and wrap width equals text width. Now Python doesn't care. Python's like Honey Badger. Python does not care. I won't say it quite the same way. If you guys are familiar with that internet meme. So Python doesn't care how you say it, but this makes it very clear to you that you're specifying the parameters window, string, font, height, and wrap width in that exact order, right? And it's less confusing, I think, overall, because you both know the name of all the parameters, and you also know that you're specifying them in the right order. So if I want to do that over here, again, I could sort of do the same thing. I can move the window parameter back to the beginning where it's expected to be. Window equals my window, string equals that. Then it's going to be font, height, and wrap width. So I want to show you this because I want you to sort of know why you'll see these things in Python code, although I think for you guys, although this is nice and flexible when you really, really know what you're doing, for you guys, so that you don't confuse yourselves, I think it's probably going to confuse you the least if you use all the information that you have available to you, both the order and the names of the parameters. Okay, so we've got that there. If we want to follow that same convention down here, we'll say window equals my window, string equals I knew it, blah, blah, blah. Font equals courier new, height equals 36, wrap width equals text width. Okay. So that, again, should work okay. Should just do what it always has done. No. Yes, okay. All right. So basically, we've moved around and added and subtracted a bunch of lines of code, but we've hopefully made our text or our code a little bit more readable. Now, there's one other thing I want to show you that you can do with Python functions, and then we'll maybe take a little debugging break before we move on. So one other really nice thing that you can do with Python functions, which is going to make your life a bit easier, is you can actually say, you can have the function definition say, you don't actually have to give me all this information if some of it you're okay leaving at default values, right? So like, oftentimes, if you have an application or something like that, you have all these settings that you can adjust, but most of the time you just leave them all at the default values, right? You install Microsoft Word, it's got a bunch of preferences, most of them you never look at, you just kind of leave them at their defaults, right? So Python can also do this when you define a function, which is another thing that makes life a lot easier, is you can define default values for these parameters so that if you don't really care when you're calling the function, it'll just use these values by default. And the way we do that, and again, this is a little bit confusing until you get used to the syntax. Just looking at what our values are. So you put a little equals assignment up here in the def line where you define the function. So where you have the font height, you can say height equals 36, for example. And basically what that means is now if we put that in there, it's okay when we call the display my text function. It's now okay if we don't even bother to specify a height at all. If we don't specify a height, it'll just default to 36. Right, so let's try this and see it in action, right? So we put height equals 36 in the def line. Now what we're going to do is just take out the height specification when we call this function. Yeah, let's take it out down here as well. And in theory, this should work exactly the same way, even though we've now taken out specifying what the height is. So give that a try. Should look exactly, oh shoot. Oh. All right, I took out one thing. I was being lazy. So, so if you do this, all right, so another catch that you have to do is if you do, in fact, do this, the things that have what are called default arguments, right, like default values, you can't have a parameter in your function that doesn't have a default value after one that does. So I was going to add this later, but let's just go ahead and add it in now. So let's say the default wrap width will be 800. Okay, so now everything from this point forward has a default value, and that will let us run. So let's see how that goes. Okay, runs just like before, right? So that, oops. What did I do? Okay, there we go. So that still runs. So this is also going to make our code a little bit more readable, right? Because what we can actually do now, let's do one more thing. Let's even specify a default font in our function, right? So we could say we always want to use Courier New. And now what we can do is actually take out of these function calls the font, the wrap width, and the height. If we always just generally want those to be the same, we don't have to worry about those details every time we call the function. We can just say, this is the window to draw it on, and this is the string I want to draw. And that's all the information you really need. I don't care about the details. I'll let the default values just be the default values. Okay? So let's take all that stuff out. And that actually simplifies our code even more, right? It doesn't reduce the number of lines, but it reduces the amount of complexity on any given line, because now you've just got the window and the string. Let's see if that still displays okay. Okay, still looks exactly the same. It's very good. So that's good. So that means this function's taking care of the default values if you don't put them in. But if you ever want to change the default values, you still can, right? You can always just add those parameters back into the function. So let's say we want to, for some dumb reason, we want to make this text really tiny. We can just add in a parameter saying height equals 12, right? So now here we're passing in 12 for height. And what that means is when the function's actually called, it's going to say, well, I had a default value of 36, but you've given me a height of 12. So the value you pass in overrides the default value. So now on that second slide, okay, I'm going to try to guess it now. You have a very, very tiny, right? So now we've overridden that default value. So that's really the best of both worlds, right? Because, you know, this is how real software works, right? So you have settings that you can change if you want to, like you do in Microsoft Word or something like that. But what you don't want is the first time you ever run Microsoft Word, you don't want to sit there for an hour and have it say, so when you open up a blank document, what font do you want it to start off in? And do you want me to show like curly quotes when you type a quote mark, or do you want it to just be the straight ones? And do you want me to have autocorrect? You could sit there for an hour if you had to set all the parameters, you know, before you could use anything, right? So this is sort of the best of both worlds. So you can have default values, but also change them whenever you need to change them, right? So that's basically the idea here of having functions with arguments and the arguments having default values and so forth. Now, I am assuming that you guys are all thoroughly confused and none of your code actually works. Is that correct? Do you have a question? Okay. All right, so it gets a bit tricky. We're not going to be able to add a default value for window. Okay, so I mean, it's pretty clear what like height is, right? Height is an integer. So that's a very easy thing to specify a default value for. The window that we're taking in here is a window object. And a window object has to be created with PsychoPy's like psychopy.visual.window function. So it's hard for you can't really specify a default window to draw something in because like the code down here creates that window. You know what I mean? I'm trying to think of a good way to say this. So it's easy to have a default font name or default font height because those are just numbers and like strings and things like that. But a window is a thing that you have to make. And you have to actually like, in other words, there's no such thing as sort of like, I mean, I think there might be a way actually in PsychoPy to specify a value that means whatever the main window is, but for our purposes, it makes more sense for us to always create a specific window that we want to draw into. Oh, okay. Oh, yeah, that's a good point. All right, so great point, guys. All right, so I was hoping to avoid this idea, but we'll get in here. All right. So what we need to get into to discuss this is the idea of namespaces, okay? So you don't have to understand this whole concept. The whole point here is that this function here does not know about any of the variables. This function here is its own little universe, okay? So this function only knows about the values that are defined inside this function. This function does, if you try to refer to display resolution, or text width, or image file, or my window, or any of those variables, this function has never heard of those things, okay? So the whole idea here is this function, the only variables or names that this function knows when it starts running are window, string, font, height, and wrap width. And then anything else it creates. So like then it uses those to create something called my text, but it doesn't know about anything else in your script except what you explicitly send it, right? So that's the whole reason of why functions need parameters. So it's like saying, here's the information I'm going to give you, but you don't know about any of the other information. So when you call a function, the function doesn't know about any information in your program except what you give it. Does that make sense? So basically what you're giving it is you're giving it these 5 things and saying, you know, do what you need to do with that information. But you're not giving it access to any other information than what you need. So it's, you know, again, you can think of the function as being like your little, you know, worker doing your job. Okay, so example again, if your function is like your toaster, right? If you need the toaster to do its job, you give it some bread and a darkness setting. You don't need to tell the toaster how tall you are, how much you weigh, what color your eyes are, what your favorite food is. Toaster doesn't need to know that stuff, right? Toaster only needs the information from your world that you give it, right? So to perform a function, you only give the function certain specified information, and it doesn't know, it has its own set of names that it refers to things by, right? So it gets a little confusing because, like, for example, the window object that you pass in. So down here in this code, you create a new window and you call it my window, okay? And this is a PsychoPy window object. But when you send that window into the display my text function by saying window equals my window, then when you go into this display my text function, the name it uses to refer to that same object is not my underscore window, it's window. Does that make sense, everybody? So you are sort of giving it some information of yours, but it's referring to it with its own name. Does that make sense? So like, okay, so again, using the toaster analogy, like if you have a toaster and it takes in, you know, bread and a darkness setting, and to do its job, it takes in those 2 things. You could pass it, you know, Italian bread, or if you have French bread, or if you have, whole wheat bread or white bread, right? So you can take whatever bread you have and give it to the toaster. The toaster function is just going to call it bread because that's the name that the toaster has for whatever you've given it. Does that sort of make sense to you guys? So whatever you pass in, at whatever window or whatever string or whatever font you give this display my text function, this function will refer to that until the function is done, just as window or string or font, regardless of what that variable's name is out here in the main world of the script. Does that kind of make sense to people? It's probably blowing people's mind a little bit. All right, so now again, so I'm assuming everybody's mind is blown, and we need to stop and debug. Is that accurate? So we've got a crash where I think you've got basically this, right? So you have down here where we'll create this text sim, you have string equals my string, and if you try to run that, that will crash. Okay, right, and you get this thing, unexpected keyword argument string, and you've got a crash in line 35. So if you go to your PsychoPy reference, I'm not sure how that crept in there, but that's okay, because this is a good example. So if you ever need to look up what parameters a function in PsychoPy is expecting, you can Google the module in question, right? So you're having an issue creating the text stem. This is where these parameters and their names come in really useful, right? So when you create a text stem, there are actually all these. So if you look this up on the PsychoPy website, this is a description of that function text stem that creates a new text stem and all the arguments you could possibly send in. So you could give it a window, some text, a font, a position of the text, a depth, which you don't have to worry about what that means, color information, color space, opacity, so you can make your text transparent, the units, the orientation, so you could rotate it, the height, whether it's anti-aliased, whether it's bold, whether it's italic, whether it's aligned, blah, 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 right? So when we've been making these text stems, I've been simplifying life for you guys by only passing in 3 or 4 parameters. But anyway, the relevant thing is, it also tells you what the default values are for these things, right? So if you didn't actually specify any text at all, it would say hello world. But of course, you don't want it to say hello world every time, so that's useless. But the key thing here is that you learn that the name of this argument is text, okay? So that's just a choice of name. So when we wrote our function, display my text, we called the name of the text that you put in string, but the text stem function built into PsychoPy refers to the text as the word text. You know what I mean? This is one reason it's a little annoying when you give your variables really boring names like text and string. It's a little bit hard to talk about them, but the idea here is that it uses the name text to refer to the text that you send it. So you need to say text equals whatever instead of string, right? And again, that's just a choice of names. You could call it my cute little texty bear, and that would still be fine. It's just that you tend to use descriptive names. As I was starting to say, sounds like everyone's got their functions working. I realize that this is conceptually difficult, so maybe I will put some more functions stuff on the problem set number 3, so that you guys can work through it, so that you can help yourselves figure it out by virtue of doing this, because you will need to use functions in your life. So I'm not going to ask hard questions about functions on the problem set, but maybe I will now ask a bunch of questions about functions so that you can figure them out by virtue of doing the problem set. Okay, well I think this will make, I think what we're about to do will make things make a bit more sense to you. Because I think one thing that's probably confusing people is this issue of what we call namespaces, what names you can use to describe things, okay? So let's do this. So like I said, it's a bit annoying in Python that your functions have to occur. This is just a thing that's part of the language. If you use the name display my text, the name of this function display my text, it has to occur in this file, in this text file, earlier in the file than the point where the name is used, right? So the point is, functions are a bit weird, right? So this chunk of code that I've got highlighted here, this doesn't execute in its own place, right? So this code doesn't actually run until you use this name down here, right? But it's defined up at the top of the function, but you have to define it earlier in the function than where it's used. So as an example, let me take this chunk of code and put it down at the end of the function, or at the end of the script rather, sorry. And if we run this, we'll just get an error saying display my text is not defined, right? So what's happening is Python starts at the top of the file and goes down, right? It gets to the point where it says display my text, and it looks for some function named display my text, and it can't find it if it hasn't been already defined. Okay? So to make life easier, what we really want to do is we really want our function definitions out of the way of our main code, right? Because the idea with a function is you want to write some code to do a particular set of actions. You want to get it just right so that you can do several things in just one line of code. And then you want to forget about it, basically, right? So ideally what we would do is we would do that by putting this in a completely different function, or a completely different, a different file altogether. So let's do that, and I think that will both make it conceptually a little bit easier to see what we're doing, and also a little bit closer to how you would actually do this if you were writing real code. So what we really want to do, let's make a little file, a new Python file, and let's call this, what did I call it here in this example? Let's call it helper, oops, sorry. We don't need to call it anything there, but let's call it helper functions.py. Okay? So, in other words, these are just little functions we're going to define that help us out to do our job. And let's just take this code, cut it, this def code, and paste it into this helper functions file. Okay? So now what we're doing is we are putting this function into a file, and essentially what we're doing is we are starting to create our own Python module. Excuse me. Our own Python module. So remember we talked about modules before, right? So we've got modules like PsychoPy.visual, PsychoPy.event, we've got modules like random. So a module is really just, what a module really is a collection of function definitions in an external file that you want to be able to use, okay? So creating a module is nothing difficult. It's really just making a function definition, putting it into its own file, and then importing that file. So if we want to do that, we've already put this into a different file that we've called helper functions, and we just want to import that file along with everything else. Okay. So what that's going to basically do is it's going to say, all right, now look for a file called helper functions, and it assumes it's going to end in .py. You don't have to put the py at the end. So it's going to say, now before I run any code, look for a file called helper functions and give me access to the functions in there. Okay? So if you've done that, if you run your code, it's not going to work because I deliberately did not do a couple things that you also have to do. So it still does not find the function display my text. Now, does anybody have any idea why the name display my text is not quite right based on what we've done before when we've used functions from other modules? So when we imported PsychoPy.visual, how do we refer to the functions in PsychoPy.visual? Like when we want to make a window. Well, what do we use down here? We call it psychopy.visual.window. So if you use this import command to refer to a function, you generally have to put the name of the module in a dot before the name of the function that you use. All right, maybe I know this is a lot to handle right now. So then what this is saying is if we imported all the functions in helper functions.py, which right now is just this one function, and if we now refer to display my text, if we just say display my text, it doesn't know, maybe there's a function called display my text in psychopy.visual. Maybe there's a function called display my text in psychopy.event. It doesn't know necessarily which one we want to refer to if it's not in this actual file that we're running. But if we say helper functions.display my text, it looks inside the module helper. Oops. Oh, I screwed something else up. What did I do? Oh. This is the next thing I need to do. Okay, one other thing I need to do. This is actually a bug in, as you see, a bug in helper functions.py. It's saying the global name PsychoPy is not defined. Okay? Now that's because in this file, anybody see? So it's saying that it gets here when we actually use this function, and it says, what's PsychoPy? What's psychopy.visual? I've never heard of psychopy.visual. And that's because we took this definition out of a file where we had already imported the other psychopy functions, but we haven't imported it in helper functions.py. So we use these psychopy.visual and psychopy.event functions, but we didn't actually import them in this file where we're using them. So we actually have to import in any code, basically anytime you use code that refers to another module, even if some other code already imports that module, you need to import that module in any code that uses those modules. I know this is, now your brains are probably like, oh, I should have really paid attention when we were talking about modules and importing and everything before, because now he keeps throwing these terms around like everyone understands them. I know that this is like it sort of made sense before, and now you're having to put it all together, and it's probably like breaking your brains. But does that kind of make sense? So we use this psychopy.visual and psychopy.event in our helper functions file, so we now need to import those. And now if we run psychopy number guess, it should run just fine, even though our display our text function is in another file. All right, yeah. I'm not sure why that is, but you should, in theory, import both of them anyway. I mean, even if it works for, there are a bunch of weird things that PsychoPy does that are not sort of like exactly the standard Python way, but this is the more this clues in the reader of your code also that you use these functions, or you use these modules rather. So you should do it anyway. All right, now again, I don't want to break your brains by throwing too much at you all at once, but I'm going to show you one more thing before we take a stop and figure this out break. One more thing that's going to make your life a bit easier is if you have to say helper functions.display my text every time you want to display your text, that leads to a pretty long line of code, and it's pretty annoying to have to type that every single time, right? So it would be nice, ideal, if we lived in some world where you didn't actually have to do that, okay? So what if we didn't want to do this? If we just wanted to call display my text and you're like, look, PsychoPy, dude, I wrote the function display my text. I know I want to use the display my text function that's in this file, helper functions, and not any other function that might be called display my text. If you want to not have to do that thing with the name of the module and dot anymore, you can use a slightly different version of this import function. And what you can say is from helper functions, you see the from word gets highlighted, so you know that that's a special word in Python. Import star. Now, if you guys have used, sort of old school computer lingo for anything, you probably know that star is like a wildcard, right? So what this basically is saying is, instead of just import, which just gives us access to the functions in random and psychopy.visual and psychopy.event, but we still have to refer to the module, this is basically saying, if we say from helper functions import star, this is saying any function that's defined in helper functions, if we use this from word to do it, basically import it and treat it as if it's defined in this same file so that we don't have to refer to it with the module name. We can just treat it like it's defined right inside the PsychoPy number guess file, okay? So if you say from helper functions import star, then you should be able to just refer to display my text without that dot, and it works just fine. Okay, so that still works. It's great. The only thing I will say to you is I would suggest, so here's what I'm going to suggest to you guys. When you're writing your own code and you're writing a script that has functions, what I would suggest to you is put all your functions into a file like this. It doesn't have to be called helper functions, but something like this is probably useful to call it. Put your main script in one file, put your functions in another file, but I would only use this from keyword for your helper functions file. So you could, in theory, say from psychopy.visual import star, and then, like when you call ImageStem, you could just call it ImageStem instead of psychopy.visual.ImageStem. But I think it's going to be more helpful for you guys not to do that, because I think it helps for you to remember that ImageStem is part of psychopy.visual. So my recommendation is to only use this from keyword once per script, and only for the functions you define yourself in a file like helper functions. Okay, now whose brain is broken and doesn't get it? It's a, yeah, so, okay, so I know people are probably confused, but do people have questions in a way that I can explain them? You know what I mean? Like it'll help if you ask questions, because it'll help clear up your confusion. But I want to know what you're confused about. I mean, I can walk you through this more in the problem set, but I need to know, you know what I mean? Like the more questions you ask now, the easier it'll be to unbreak your brains. I know this is a big jump. Well, do people at least have the code? So do people still have the code working, or do we need to stop and debug anything? Stop and debug? So we've got a bug where I'll replicate the code. All right, so whoops. All right, so one bug we're getting is something like this, right? Where you've got, if you run PsychoPy number guess, you get a bug. And it's useful, again, I want to step through this with all of you guys because you'll start to see how this stuff works. All right, so we see name error, global name, my window is not defined. And importantly, that's happening, it says it's happening, we're going to get what we call a trace of where the error is happening. And it's happening in a sense, it's happening in line 12 of PsychoPy number guess, right, which is here where we call display my text. But it's really happening in line 9 of the helper functions. So what this means, maybe this is another way to think about this, is you want to start thinking of your programs like the way the computer reads them. So what the computer's doing is, when you hit this run button, if your current window is PsychoPy number guess, it starts at the top of PsychoPy.number guess and goes line by line, right? So it says import random, PsychoPy visual, PsychoPy.event. Okay, I'm going to import those modules. Now I know about random numbers and visual things and events, right? Then it does from helper functions import star, and it says, all right, now I know about all the functions inside helper functions, and I can call them by name. Now, and then it keeps going through. It says, all right, now I have a variable called display resolution. That's these two numbers. Now I have a variable called text width that represents the number 800. Now I have a variable named image file that represents the string smileyface.png. Now I blah, 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 run this. I create a window named my window. Now I'm going to do, okay, now I'm looking for a function called display my text. Well, where do I have something like that? I have one in this file, helperfunctions.py. So I'm going to go into helperfunctions.py and run this function called display my text. So now I'm going to do this and this and this and this, right? So what you've basically got is then you've got this like series of, so in a sense, the error is happening on line 12 of PsychoPy number guess, but line 12 of PsychoPy number guess entails going into helper functions and doing everything inside the function display my text, right? So you see that what that basically means is if you use like a little arrow to represent where your code is at any given time, there's a little arrow in line 12 here, but that arrow doesn't go on to line 13 until you finish everything in this function in display my text. Does that kind of make sense to people? So when you get an error that says it's happening in 2 lines simultaneously, and you're like, how can that be? What that really means is it tried to execute 1 line of code, and to execute that line of code, it then had to go into this function and execute all of its code. And so what you're really hitting an error on is the last thing you see, which is line 9 of this file. Now, the issue you're actually having is a good one to mention, which is that you've got, you're trying to create a text stem with PsychoPy visual.textStem by giving it my_window. Now this is a key thing. This is why I think it's good to explain this for everyone. There is no such, so this display my text function has never heard of anything that's called my_window the way it's written here. Because the name that we're using to refer to the window object in display my text is called just window. Does that kind of make sense? So the name we've given in this function is just window. So if you change that back to just window, this code will run correctly. All right. So display my text doesn't know that this window object out here in this file, we've named it my window, right? But when we give this window to the function display my text, it gives it a new name, which is window, right? So does that kind of make sense to people? So you can call the same object by different names, right? And again, this is useful. Okay, so this is useful in the case of, like, let's imagine in my main script, for some reason you actually wanted to have 2 windows on the screen, right? And call them like left window and right window. You could still call the display my text function and pass in left window, or you could pass in right window. And display my text would then write that text onto whichever window you gave it, right? But it doesn't have to know that there are 2 separate windows. It'll just write its text on whatever window you give it. Does that kind of make sense to people? So this is what's great about functions, is the function doesn't care about what's outside the function and what things are called or anything like that. It only cares about what's defined in its own little world. And it just does its job. It minds its own business. It just keeps its eyes forward, and like worries about what it's designed to worry about, and doesn't refer to things by any other name. So anyway, that's a long way of saying that if you change it to window, it should run. But the point, again, is maybe explaining like why you have this namespace issue, and like, how it doesn't know about the names names that things have outside the function. We're hitting a lot of issues, and again, it's good that you guys hit these because it'll sort of hopefully reinforce this idea of these, what we call these namespaces. But like another term I use sometimes is that people use sometimes is local names. So local names means like the names of things that are inside this function, right? So again, if you have a window in psychopy.numberGuess that's named my_window, and you give that window to display my text, what we would call the local name for that window object is just window in display my text, right? So if I use the term local name, what that means is, again, you may have an object that is referred to by a different name in your main script versus inside of a function or whatever. But the local name is the name that object is referred to in a certain context, okay? So again, it's this idea of basically you have different contexts for things, right? So if you have these like 5 variables here, these quantities might be defined in your main script, but the function only knows about its own context. I'm not sure if that makes it make more or less sense, but again, sort of the function is its own little self-contained world or context, and it only knows about the names in its context. So let's keep going a little bit. I think we are going to have to go back and do some more of this next time, which I was kind of planning on anyway. But hopefully, what I'm at least hoping is like, to you guys, putting this function that we've now defined in a separate file will reinforce to you guys the idea that you should start thinking of these functions as like their own little world of things, that are outside the world of your main program flow, right? So again, you want to think of it as like being totally self-contained, and that you just put in certain information and get back out certain information. But in other words, other than those 2 ways of communicating, the code in your function does not communicate or does not know about the code outside the function. Does that kind of make sense? Okay. Hopefully that kind of makes sense to people. Again, I'll try to design the problems in the problem set to like walk you through this, and we'll talk about it more next time. But maybe we'll keep going so that we can at least kind of get through some more examples, and I think it'll make more sense the more of it we do. Okay, so one more thing is that Cheng had asked earlier, we have another occasion in our PsychoPy number guess file where we do something very similar to what we do in the display my text function, but we can't quite reuse our code down here. Now, you see down here, we're doing a very similar thing, right? We're just making a text stem, we're drawing it, we're flipping it, and we're calling psychopy.event.wait keys. But we're doing, why can't we replace the code in here with a call to display my text as it's written right now? Yeah, so you're expecting, right. So the helper function we've defined, display my text, waits for a key press, but it doesn't bother to record that key press, right? So here, you're doing a very similar thing, but you actually care about what the key press is, right? So we can't use this function, display my text, exactly as it's written, because although it waits for a key press, it doesn't tell you the answer. So what we can actually do is we can just modify this slightly to be a function that not only displays some text and waits for a key press, but actually gives back the result of that key press. And then we can use that same function in all of those places, not just the 3 that we're already using. So let's make that modification. And now what we could do is I could just rename and change this, but for the sake of like looking and comparing, let's copy and paste into a new function, and we'll have both of them side by side that we can compare. Okay, so we called it earlier display my text because all it did is display text and wait for a key press, but it might make more sense to refer to it as something, sorry, I'm just getting my notes here to make sure I'm going to do it exactly right. So we might want to call it something that more implies that you could get an answer back. So let's call it something like prompt key press, right? Which implies that we're going to display some sort of text prompt, wait for a key press, and maybe give it back, right? And if we wanted to, you know, we've got all these notes saying what you send in. You could also say like return or will return a single output, which is the key pressed. Okay? And again, that's just a comment describing what it does, but that might be useful if anyone ever uses your code. It'll say, oh, look, you know, I can get the key pressed as an output. Okay, so we can mostly reuse the text we had with a couple critical changes, right? So if you look at what we did here, when we called psychopy.event.wait keys, that returns some kind of answer that we stored in this answer variable, and then we did this little number, which again will make more sense next week. Right now, let's just take this part on faith, okay? But the key point is that here where we call psychopy.event.wait keys, that's a function that does return an answer, but we weren't using it previously, right? So what we can do is we can say, we can call it whatever. Let's call it key press this time instead of answer, just to make it clearer that like it's just a key pressed. It doesn't have to have a particular, you know, it's not necessarily the answer to a question. It could just be a key press for some other reason. So now what'll happen is whatever key we pressed in the prompt key press function will get put into this key press variable, and then we have to do this little trick that you'll understand better next time, where we say key press equals key press square bracket 0, just like we did back here. And then we do one other tricky little thing here, which is we say return key press. Okay? Now what this says is, so this is the toaster popping back your toast, right? So this is basically saying like, all right, you have given me some bread and a darkness setting, and I'm going to work some magic, and in a little while I'm going to give you back something, right? And the thing I'm going to give you back is my toast, or in this case it's my key press, right? So back here in the function that, or sorry, back here in the script that calls that function, you can now catch that answer. You can now catch that toast, right? So this is basically what we were doing here, right? So you can see like the function psychopy.event.wait keys we've used several times, right? So back here in helper functions, it's what we were using here just to wait for a key to be pressed. It's what we're using here, but we choose to accept some output from this function here, right? So one thing to note is if a function gives you output, there's no rule that says you have to use it, okay? So in other words, if you call the toaster, if you tell the toaster to make you some toast and it gives you back some toast, you could either keep that toast or you could just throw it away. You're like, I don't care about the toast. I just wanted you to do it because I don't know why. I wanted to waste some electricity, right? So in other words, just because a function returns some output to whatever called that function, the thing that called that function may have some use for its output or it may not, okay? So the point is, now at least we have the ability to accept output. So what we can do is we can take this and we can basically take all these lines of code that make a text stem, draw it, flip it, and take an answer. And we can instead just say answer equals, and we want to call this function prompt key press just like we call display my text, right? Because prompt key press and display my text are basically the same function, except that now prompt key press returns some output, but we didn't change anything about what we put in to prompt key press versus display my text, right? So we give it the same things: a window, a string, optionally a font, optionally a height, optionally a wrap width, right? So we're going to give it a window, which is still named my window. And again, I recommend saying window equals just to make it clear that you're giving it as the window parameter, you're giving it this object that we're calling my window. And the string we want to give it, we've already defined right here as my string, right? So we can just say string equals my string, right? Because we created the string that says, is it some number, yes or no, in this line. So now we're just going to give it that string, and we're going to take whatever prompt key press gives back to us and put it in this variable named answer, and then everything else should run just like it did before. So if we save that and run it, okay, I'm going to have to change that back to full-size text at some point, but that's fine. All right, still runs just like before, right? Awesome. And if we really want to, what we can do now is we don't really need this function display my text anymore, right? Because prompt key press does everything that display my text did, but also can give you output, right? So if we want to, we can just get rid of display my text now, right? Because hopefully you guys see the comparison. So we can get rid of that, save it, and all we have to do here is replace these calls to display my text with calls to prompt key press. Here and here, and then once again down here. And run it again, see if that still works. Okay, so it does, right? All right, awesome. So what we've got here is one still pretty simple function, right? Still only 1, 2, 3, 4, 5, 6 lines of code that displays some text on the screen, waits for a key press, and then returns whatever key was pressed to the script that called that function, right? And we've actually now cut our code down in our main script to only, get rid of that blank line, to only 32 lines of code, including a couple of comments and some blank lines, right? And this is only 15 lines of code, most of which are comments mostly, right? So that, it adds some conceptual complexity because I know you guys are not still used to thinking about functions, but it greatly simplifies how you read the code now in your main script, right? Because instead of having these 4 lines of code or 5 lines of code every time you want to display some text on the screen or get a key press or both, you just have to call this one function, right? All right, so that's pretty cool, right? Does that kind of make sense? Does everybody get that? Do we need to stop and debug again, or is everyone kind of still on board? Okay. Well, I'm going to hope you're on board because I want to. So, this took longer than I had planned, but that's still fine because fortunately I don't really have much of a plan from week to week. So I can plan next week's class depending on how far we got this week. I mean, I do have a vague plan, but I design each lecture after the previous one. So what I want to at least get through though is the next idea, which is PsychoPy.sound, because I did promise you sound today, and then maybe we'll pick up the functions idea next time. But I do want to show you guys at least what you can do with the sound module, and then next time what we'll probably start doing is building. Good news for you guys, we're going to get rid of this number guessing task and start building sort of a more real psychology experiment, like a psychophysics style task. I was going to start today, but we'll probably start next week. But in order to do that, let me introduce the module sound. Fortunately for you guys, after all this difficult function stuff, conceptually, PsychoPy.sound is super duper easy, okay? There are only really like two functions you'll probably need in PsychoPy.sound. One of them is PsychoPy.sound.sound, which is a little confusing, but this is the function named sound inside of the PsychoPy.sound module. And all it does is create a new sound object, right? So if you are familiar with like making a text stem, making a circle, making an image stem, same basic idea, right? You just call this sound function, give it some parameters, and it creates a new sound object. And we'll talk in a second about what those parameters are. And there's a function that's part of the sound object called play, and that plays the sound you make, okay? So you have a function to create a new sound object, and you have a function to play it. That's pretty much all you need in the sound module, okay? So the only fine details to worry about are what parameters you can use to create a sound object. Okay, so if you look at this function specification, there are a bunch of parameters you could pass into the sound function to create a new sound object, but the only ones we really care about are the ones called value, sex, and octave. And you only actually care about more than one of these in a couple of cases. All right. So the most important one is one called value, and I'll show you how this works in just a second. So basically, what you choose to pass in as the value can take several forms. Now, and this is something we haven't talked about yet. Like what we said when we wrote our own function is you need to give our function like a window and a string and a height and all these things, and one has to be a string and one has to be an integer and so forth, right? But if your function is written the right way, and this is well beyond what you guys will have to do, but this is something PsychoPy can do, you can actually give the value parameter several different things, and the function will know what to do depending on what you give it. So this will make more sense in just a second. So for example, if you assign value, this parameter called value, to be a number, then the sound it's going to create is going to be a pure tone or a sine wave at the frequency in hertz specified by that number. So if you say value equals 500, it'll create a 500 hertz sine wave. Okay, does that kind of make sense to everybody? We'll do this in just a second, but so you'll see this in action. So if you make value, instead of making it a number, you make it a string that looks like a note name. For example, the string A, or BFL, which is how you indicate B flat, or CSH, which is how you would indicate C sharp, or something following that pattern. Then you can make the sound a musical note. Now, if you make it a musical note, you also have to specify an octave. So that's that third parameter that we specify. So for sounds, which parameters you specify sort of depend on what you specify for value. And lastly, if it's a string, but instead of a string that looks like a note name, if it's a string that looks like a file name, then the sound will be whatever sound is in that file name. And you can use WAV files or OGG files, if you guys are familiar with OGG files. OGG files are kind of like, it's an open source sound format, kind of like MP3, but freer. PsychoPy claims it can also play MIDI and MP3 files, but I have not had success making that work, so I suspect you guys will not also. So for the most part, let's assume WAV files are the format you want to use, but you can also play a WAV file. All right, so value can take on all of these different forms, okay? And it can be any of those types of information. Now, the other two are a little bit simpler. So sex only takes on one, well, sex can take on multiple forms, but the variable named sex can only take on one form, which is a number, a decimal number, which is the length of the sound in seconds, okay? So this only matters if you're giving it a musical note or a sine wave, right? Because if you give it a file name, it knows how long the song in that file is. But if you tell it to play like, an A sharp, you have to tell it to play an A sharp for like 1 second or 10 years, right? Because it makes a difference. By the way, you'll find in PsychoPy and in Psych Toolbox next semester, there are a lot of variables named sex. And the jokes get even funnier in Psych Toolbox, so just wait for it. And finally, there's the question of octave, right? So like I said, if you specify that the sound is going to be a musical note, you have to specify which octave it's in. So like the first octave, the second octave. If this may make sense to musicians, the rest of you will probably not use this very much, except I'm going to make you use it on your problem set. But you have to specify an octave. So basically 1 are lower octaves, 8 is a higher octave, and it goes from 1 to 8. You'll probably want to use like 4 or 5, because the really low ones you can barely hear, and the really high ones are like, painfully high. Okay? So let's see an example of this in real life. So you guys can all do this. This is going to get kind of obnoxious probably if you all do this, but that's fine. So you might want to make sure the volume is up on your computer, or that you have your headphones plugged in or whatever. And actually, this is so simple that what I'm going to suggest to you is that we just do this in this shell window, that we not bother to write an actual script, okay? So this is the same as if we wrote a little script to do something, but we're just going to run all of these Python commands right in the command line here. So just go over to your shell window here. You might want to pull this up so you have more room. And the first thing you're going to need to do is say import psychopy.sound. Whoops, sound. Okay, so that's what you're going to have to do, just like always, to make sure you have access to the stuff in psychopy.sound. And if we want to create, say, like a 500 hertz tone, I'm going to make sure my volume's up. This is probably going to be really loud to you listening to the podcast, but hopefully that's okay. And if we want to say like my sound equals psychopy.sound.capital S sound. And one nice thing is it gives you what the parameters are. So you see that you can actually pass in things like sample rate and bits and so forth, but we don't care about any of those things. Right now we only care about value and sex. So let's say our value is, I want to make a 500 hertz tone for, let's say, half a second. I can do that. Okay, so that creates a sound object called mySound. And then if I want to play it, I just call mySound.play. Hey, I made a sound. All right, you guys want to make some noise? You do the same thing. Again, you could do this all in a script. So if you prefer, you can make like a little script called like, soundtest.py. And you could say import psychopy.sound, my sound equals psychopy.sound.sound, value equals 500, sex equals 0.5, and my sound.play. So it's the same thing whether you put it into a script or enter it all in the command line. It's really whatever you find easier. Whoops. Oh, except with one minor distinction. So it's probably actually better to do it on the command line, because if you write the script, it's going to end the script before it actually finishes playing your sound. So actually, I take that back. Just do it on the command line for now. Okay. So it's not working. Okay. All right. This is, guys, why aren't you all using Macs like me? Okay. Well, okay. So to explain for posterity in the podcast, this is a little bug in this version of PsychoPy that I may have to see if we can fix on all of your PsychoPy installations before next time. So maybe it's actually best that we didn't get too far today. All right, so unfortunately, I'll have to see how much I can fix these before I put a bunch of sound stuff in your problem set. I think I can get it all fixed. But that's good to know. Okay, so, well, anyway, you'll just have to trust me then on these next little things, and I won't make sound too big a part of the problem set unless I can fix this stuff. But just take a look at how this works. I'll just do it and show you guys for the last couple. So I just want to specify the different ways that you can create a sound. So if instead I want to specify a musical note, I could do something like psychopy.sound.sound. All right, so who's a musician in this crowd? If you're tuning your instrument with with an orchestra, what note do you use to tune to? What? No, you don't. Use concert A, right? Isn't that what you use usually? Concert A, like A4? Let's say you do, because I know what that is. So I thought you used, I'm pretty sure you use A, don't you? Is it C that you always use? I don't know. All right, never mind. Well, middle C is fine, but I'll use A for a specific reason. It is true that A4 is a standardized tone that you use in tuning things. So let's do this. So let's make it like 2 seconds long, for example. And my sound.play. All right. So that's the note A. Oh, you know what I didn't do is I didn't put in an octave. So it defaults to a certain octave. But if we want to do it specifically, we can say my sound equals psychopy.sound.sound. Value equals A, sex, let's just make it 1, and octave equals 4. So that'll make the same actual tone because the default octave is 4. Right? Again, this is that idea of default function, default argument values, right? So if we wanted to do the same thing but an octave higher, you can do it like this. Right, same note, but an octave higher, if that makes sense to you. And the only thing I wanted to point out is that these are specified as musical notes, but there's really no difference between a musical note and a sine wave, right? It's just that a different way of referring to the same thing. So I happen to know that concert A is the same as 440 hertz. So if we were to specify it as sound.sound, value equals A, sex equals 1.0, octave equals 4. So my sound. So here's concert A again. But if we want to call it, let's call it second sound equals psychopy.sound.sound. Value equals 440. Sex equals 1.0. Second sound.play. All right, everyone can agree that's the exact same thing. So it's just really 2 ways of referring to the same thing. And I know we're at time basically, but if you guys had this working, you could have, let's see, let's specify an actual sound file. So let's say my sound equals psychopy.sound.sound, value equals, and I have a wave file here called sound1.wave that I was going to have you guys download from the Google Drive, and now you can just hear it instead. My sound.play. All right, so you can play. So that wave is just a wave of a cat meow. So you can see, like, if you wanted to have sounds in your task, it's pretty easy to do, right? You just have to have a file, and you just use these 2 lines to create the sound object and then play it. And then, you know, I can play the sound as many times as I like. So if I want to say for, you know, my counter equals, or in range, or let's say X range, because we're doing that now, right? 5, my sound dot play. Oh, and then I actually have to do a little something that, well. Okay, that's not actually, I was going to play it 5 times in a row, but actually I need to add a little special sauce to make that happen. So maybe I'll, for the sake of all your ears, I'll just not make the cat sound play 5 times in a row. But the point is, it's very easy to play the sound once you've loaded it in. And this is useful in any task where you want to use sound. Like Waylon and I do this when we use audio recordings where we audio record the subject responding, and we also make the task play some beeps at the beginning of the task so that we can synchronize the digital recording to the actual task timings. That's one thing you can do. Or if you actually have a task that involves sound, like a psychophysics task or some task where people have to listen to people talking or something like that, it's very easy to load in a sound from a file and play it, or play sounds of certain notes and frequencies. Okay, so didn't get quite as far as I hoped, but that's all right. We'll maybe pick up a little bit of this next time, do a little bit more functions, try to fix the sound so that you guys can do your own sound stuff and make a real racket in there, and we'll pick up with the data types and stuff that we're going to do next week. And if we get a little behind, that's okay, because we actually have like some buffer time built in before the end of the semester, so it should still be okay. All right, so any formal questions for posterity before we call it a day? All right, so thanks again. Sorry about the sound issues. We'll try to fix those. Blame Microsoft. And so I'll stop the podcast now, but if you have any questions, I'll stick around. All right, thanks.